Solving systems, okay? This is this whole unit or bundle. I don't know why it's called bundle. Why not it's called unit? It's weird. Bundle, and then next year what is it going to be? Like, bundle, what's next? A bag? Bag one. You know what I mean? Just stick to unit.
I feel like it's always been bundled.
Here or something. I don't know. When I moved here, I'm like bundle one, bundle two. I don't get it. So solving systems by elimination, y'all. So this is the first question you have, or the first set, but I only picked one because this is just introducing the concept elimination strategy. Just understanding the strategy of how to eliminate. And what is eliminate, actually? It's just, you have two equations, linear equations. So, okay, we're just dealing with linear. And you decide, I'm going to add the two together, or I'm going to subtract the two together, and you have a new equation, okay? So this plus this, what's my new equation? And from that new equation, what am I trying to say? You'll find what x or y is. Okay, that's the whole goal of what we've been doing the past 2 or 3 days. To solve a system, you're trying to find the value of x and the value of y. So here is just a strategy question, just introducing it. We're not really doing it heavy. So I'll do one of these and one of the next set, which is also a guided thing. You'll see. But let's just answer what they're trying to ask from us. A variable needs to be eliminated to solve the system of equations below. Choose the correct first step. All right. So the way I look at it is I put like like back in elementary school, you have 3 and 2, and you put that bar and then you put plus, right? That's 5. Or in elementary school, remember you do 5 and 2, you put that bar and then you minus, right? That's what we're doing here. That's what that bar I put under there is. And the question is, should I plus or should I minus? Those really are the only two options. We're not multiplying the two equations or dividing, plus or minus, okay? So the keyword is, the keyword is elimination. The keyword is elimination. If I add these two equations together, is something going to eliminate? Is something going to cancel to 0? If I add all of this to all of this, what's going to go to 0? This right here, okay? So we're definitely going to add. So instead of subtract, we're going to choose add this time. So if I add, so honestly, let me just do this whole problem, you know what I mean? And then just hit 3 birds with 1 stone or something, you know? So let's just do this problem. And honestly, let me just erase these. We don't need that. But it's hard to erase, apparently. My God, okay. Yeah, because why do like 3 problems and each one is like a small step towards how to do it? No, maybe 2. It's definitely more than 1 bird. It can't be 1.5 bird. How do you kill 1.5 birds? Yes, but I'm trying to say with 1 stone, I'm gonna kill 3 birds. I'm gonna get 3 stuff done with that 1 stone. So get off my case, man. Do you call me Chuck E. Cheese? Chuck Norris? Why?
Do you know who that is?
I do. Why am I Chuck Norris? Because
She said
3 birds with 1 stone.
That's funny. That's what Chuck Norris does, I guess. All right, so back to what we were doing. We decided that these 2 equations to eliminate, to get one of the variables to cancel out, plusing or adding would be the correct procedure. So how do...
68.75. Can you round that up to a 7?
No. All right, moving on. So, I'm
I
sorry,
hate it here.
but you like me.
I hate it here.
But you like me.
I like not failing math.
Well, it's not a big deal.
But it's fine.
All right, good. All right, moving on. So when we're adding, we go down the line, okay? We have 3 terms that we have to add. So negative 8 plus 10 is 2. So 2x here. These cancel to 0, okay? So don't even put plus 0 or minus 0. Just, it disappears to 0. Or it's 0, so just leave it blank. All right, negative 48 plus 56. That's just 56 minus 48. So what is that? 8? 50. I can't do math. Can't math. It's 8, right? All right, so the equation, you see what I mean? From those two equations, we added and we have a new equation. But that new equation has the same solution. See, I'm going to solve for x, and I'm going to get 4. So that x equals 4 satisfies this equation and this equation. Very interesting. Like, it looks like we're doing some crazy nonsense, we're getting something totally different. But no, this new equation follows the same solution to those. Hi, is Thomas? Tabitha is often not here first period. Often. Sorry. No problem. Okay, so 2x equals 8. X equals 4, okay? All right, but we're not done. The solution is a coordinate point, right? Or an x-y combination. So we got 4 comma something. But what's that something? That something is the y. How do we find the y? How did we do it yesterday? How did we do it? Sorry? Plug in x equals 4 to find y. So it doesn't matter which equation we use. I always told you to use the easiest one, right? What you think? They're both pretty complicated looking. I'll just take the second one. So I'm going to rewrite that, right? But instead of x, I'm going to erase it and substitute it or plug in 4. So 10 times 4 minus 4y equals 56. And what do we have here? Well, we have an equation with only one variable. An equation with one variable, well, you can easily find what that one variable is. Just solve for y. We don't need to go through all this big song and dance. That's 7th grade stuff. In the end, you're going to have y equals, well, geez, okay, I need to do that in my head. 10 times 4 is 40. Subtract it over there. Negative 4? Okay, and then divide the negative 4. 16 divided by negative 4. Okay. So, like I've been saying, it's like if I can make the notes as concise and to the point as possible, that's the best method. So this is good notes right here. But as I do it with you, I'm helping you fill in the gaps where I don't show all the work. Because if I show too much work, it's just daunting and it's like a mess, you know? All right, so the solution is 4 comma negative 4. That's a fact. That's what we have. But yikes, what was the question that they're asking? What's the first step? What was the first step we did? Add. Okay, so we answered that. We should always answer the question, read the question, answer the question. But like I said, we're just jumping ahead and just doing the problem and solving for x and y. So the solution is that point. Don't even think about point. Point refers to graph. When we're dealing with elimination, it's just algebra. What can we call it? Just a xy pair? Ordered pair, that's the word. Ordered pair. X comma y. It's in that order, x and y. It's a pair. The solution is a number ordered pair. All right, I'm rambling. Moving on. All right, here's one more problem. It's a elimination guided practice. There's only one of these I assigned to you. These are just introducing type questions to make you understand it in detail. This is the last one I'll do. I'll answer the question they're asking, but I'll also go ahead and find the solution to that system with elimination, okay? And once I do that, I think notes will be done. All right. Solve the system equations, 4x minus 5y. I'll go ahead and write it over here. And of course, you don't need to be writing this. You can just follow along. Take a picture in the end if you want, but if you can write if you want, and yada yada. Okay. So here's my system of equations, linear. Solve the system equations, this one and that one, by combining the equations. Combining. All right, what do they mean by combining? They mean like bar and then either add or subtract. Okay, looking at it right now. If I add those two, will I get a good equation? What do I mean by good equation? If I add those two like I did last problem, is my new equation going to only have one variable? You understand the question? If I add those two, well, let's just figure it out. If I add those two, 4 minus 7 is negative 3x. Negative 5 plus 9 is plus 4y equals negative 2. So I kind of just told you what the new equation is, right? Is that a good equation for us to use? The answer is no. Why? Because it has both x and y. The new equation has both x and y, so it's no use. It's a legitimate equation, but our new equation should only have one variable. Because once you have one variable, you can solve for that variable. Okay? Thanks. All right, so let's look at this. What do they do here? They put parentheses around the first equation and parentheses on the second one. Because what do you think they're going to do to the whole equation? What do you think this empty box is? A number, obviously. What is that number going to be doing to the whole equation? Come here. Important question. That number is going to multiply. So you see some number is going to go here that multiplies to the whole equation. That's allowed. If you multiply anything to the left side, you have to multiply to the right side. If you do that, the equation is okay. And if the equation is okay, you don't change what the solution is. If the solution is 2, 2, even if you multiply this by 1.11, it won't change the fact that the solution is 2 and 2. You understand? You're going to multiply it to the left side and the right side and nothing changes, so the solution will not change as well either. All right. Yeah. Here's what I'm going to do. I'm going to multiply the first equation by 7. And then I'm going to multiply the first one by 7, the second one by 4. And if I distribute the 7 to each term, this is what the first equation looks like now. If I multiply 4, Lord save me, sweet baby Jesus, God in heaven. All right, so 4, I'm going to distribute it to each number in the second equation. Negative 28x plus, what's 4 times 9? 36? 32? 36, right? Yeah. Thank you. And then 4 times negative 2 is negative 8. All right, boom. So I told you what I'm doing. I multiplied the first one by 7, the second one by 4. Why did I do that now? Why did I do that? What is the goal? What was the benefit of doing that? Sorry? I can combine it now? Yeah, our goal is to combine, right? If you add the two equations, something should eliminate. You're saying x would eliminate? Is that true?
Yeah.
It is. Now I can add it, right? And if I add it, x will eliminate. My new equation will have one variable. And that's good. That's what we want. That is elimination. So now you see why I picked 7 and 4. Because 7 times this is 28. 4 times this is negative 28. Oh, so those two numbers benefit us. Because these are the new two equations. I can add, and then I'm going to use elimination to find x and y. Very good. All right? That's what we were doing. Use the multiply as you wish. Sometimes you can multiply both, or sometimes you only need to multiply one of the equations. Just understand that multiplying the whole equation is acceptable. Just left side and right side must be multiplied the same way. You might need to do both or only one, okay?
So when it comes to a set, like those numbers on the side, we can use whatever numbers we want.
Absolutely. 7 and 4, I just thought about it. What's the easy numbers I can think of at the moment? 4 and 7. Because 4 times 7 is 28. Negative 7 times 4 is, so whatever numbers you want, that works to get something like this. You don't have to end up with this. But what is this? What's special about this? these two equations have elimination capabilities, you know. If I add these two, something's going to eliminate. So you're going to do it your way, but it probably won't be looking the same way. So once we add, add this down, that cancels out to 0, right? Very good, that's what we wanted. Negative 35 plus 36 is 1, so we got 1y. And 0 plus negative 8, that's negative 8. Boom, y is negative 8. I love it. That's good. So we got half of the answer. We got half of the answer here, y'all. I hate this. Okay. Okay, so we got half the answer. The solution we have so far is the ordered pair, something comma negative 8. Because y is negative 8, the second number is negative 8, but what's the first number? The x value. How do we find that? How we usually do it. We have y, use that to find, whatchamacallit, x. So let's take this equation, bring it over here, rewrite it. So negative 7x plus 9 times y. But hey, we know the value of y. Why write y again? Y is negative 8. We found the answer to that riddle. So forget y. Y is a placeholder for 8, negative 8. So plug in negative 8. All right, so you'll do this whole song and dance, which is called solving for x, to find the value of x. This whole song and dance, you'll end up with, yikes, let me think. I don't want to show all the work. There's no point of that. I want to keep the notes sweet and concise. 9 times negative 8 is 72, negative 72. And then I want to add it over there. Oh, yikes, sorry. Answer is negative 10, yo. Yeah, that was a little bit tricky. But you can do it, you know how to do it. Just follow the steps and you will get x equals negative 10. So boom, negative 10 comma 8 is your solution to that original system. And elimination is the process to get that that solution. No matter what you do to the equation, multiply left side, right side by some crazy number, and add and combine, and the solution was always negative 10 comma negative 8, okay? All right, good.